In this lesson, we're going to be focusing on evaluating limits at infinity. In this question, we're given root 1 plus 4x raised to the power 6 divided by 2 minus x raised to the power 3, and we're going to evaluate it as x tends to infinity. So if you look at this question, you see that we have a radical term on the numerator and then a polynomial term at the denominator. So each time we are faced with this kind of problem, the first thing we're going to do here is to divide every term here by the highest order of the denominator. So in this case, the highest order of the denominator is the variable that holds the highest exponent. Here it is x raised to the power 3. So we're going to divide every term here with x raised to the power 3. So we write limit as x tends to infinity. So let's start with the denominator first. So we have 2 over x raised to the power 3 minus x raised to the power 3 over x raised to the power 3. So how do we incorporate x raised to the power 3 into this square root? So we know that x raised to the power 3 is equals to square root of x raised to the power 6. Alright, if you want to get back x raised to the power 3 from this, we write x raised to the power 6 all raised to the power 1 over 2, representing this square root. So we have x 6 times half is equals to 3, which is what we have here. So, and we also know that square root of a over square root of b can be written as square root of a over b. Alright, so I'll just go ahead and divide each of the term and the numerator with x raised to the power 6. So we're going to have square root of 1 over x raised to the power 6 plus 4x raised to the power 6 over x raised to the power 6. So we have limit as x tends to infinity. Then we have 1 over x raised to the power 6, then plus 4x raised to the power 6 over x raised to the power 6 will be 4. Then we have over 2 over x raised to the power 3 will remain like that. Then minus this and this will cancel and becomes 1. So let's go ahead and plug in the infinity sign. That's the value of x as infinity. So this now becomes 1 over infinity plus 4. Note, infinity raised to the power 6 is still infinity. So we have over 2 over infinity minus 1. So we have 1 over infinity is equals to 0, then plus 4 over 2 over infinity is equals to 0 minus 1. So this is equals to square root of 4 is equals to 2 over negative 1. So 2 over negative 1 is equals to negative 2. And so this is the answer to this question. That's of limit as x tends to infinity of 4x cubed plus 3x over 2x squared plus 5. So we have limit as x tends to infinity. Now, anytime you are given a polynomial functions, both numerator and the denominator, and you ask to evaluate the limit as x tends to infinity, the first thing we are going to do is to divide each term with the highest power in the numerator, right? So in this case, the highest power in the numerator is 2. So let's divide, is x raised to the power 2. So we're going to be dividing each term here with x raised to the power 2. So in that regard, we have 4x cubed over x raised to the power 2 plus 3x over x raised to the power 2, then over 2 x squared over x raised to the power 2 plus 5 over x raised to the power 2. So we have limit as x tends to infinity. Now x squared and x cubed, one of these will cancel. We'll be left with 4x at the numerator. Then we have plus x and one of these will cancel. We have 3 over x. Then this is over this and this will cancel. We'll be left with 2 plus 5 over x squared. So let's plug in the limit, which is infinity. So we have 4 times infinity plus 3 over infinity over 2 plus 5 over infinity. Now this is square, but it doesn't make any sense. Just infinity square is the same thing as infinity. So 4 times infinity is equals to infinity plus 3 over infinity is 0 over 2 plus 5 over infinity is equals to 0. So infinity over 2 is still equals to infinity. So this is the answer to this question. Now, if you look at this question very well, you see that the numerator has the highest order, right? So, or highest power exponent. So each time the highest exponent is found on the numerator, then just know that the answer will be infinity. Alright, that's if both the numerator and the denominator are both polynomial expressions. So let's go ahead and solve another example on this. Let's evaluate this limit as x approaches infinity. Then we're going to be considering x raised to the power 5 plus 5x plus 6 over x raised to the power 6 plus 2. So we have limit as x approaches infinity. We're going to be dividing by x raised to the power 6 because it has the highest exponent. So we have x raised to the power 5 over x raised to the power 6, then plus 5x over x raised to the power 6 plus 6 over x raised to the power 6 over so we have limit as x approaches infinity. This and this will be reduced to 1 over x, then plus this over this will be 5 over x raised to the power 5 plus we have 6 over x raised to the power 6, then over this and this will be 1, then plus 2 over x raised to the power 6. So let's go ahead and plug in the limit values. So we have 1 over infinity plus 5 over infinity raised to the power 5, which is the same as infinity, over 6 over infinity, then over 1 plus 2 over infinity. Now 1 over infinity is equals to 0 plus 5 over infinity 0. This one will be 0 again, then over 1 plus 2 over infinity 0. So the final answer is 0 over 1, which is equals to 0. Now what did this thing tell us? Anytime the highest power is at the denominator, then the answer will be equals to 0. So far they are solving limit as x approaches infinity. So let's evaluate this limit as x approaches infinity of x squared plus 3x over 4x squared plus 4. So this is going to be, we have limit as x approaches infinity. We're going to divide every term here by x raised to the power 2. So x squared over x squared plus x squared over x squared is equals to 1 plus 3x over x squared will be 3 over x. Then this here will be equals to 4 plus 4 over x squared. So let's go ahead and plug in the limits. So we have 1 plus 3 over infinity over 4 plus 4 over infinity. So 1 plus 3 over infinity is 0 over 4 plus 4 over infinity is 0. So the final answer is equals to 1 over 4. Now what does this one tell us? Anytime we are dealing with polynomial expressions about the numerator and denominator, and the exponents or the orders are the same, then the answer is simply equals to the coefficients of the numerator over the coefficients of the denominator to the variables that has the highest order or exponent. So in this case the answer is 1 over 4, as you just see here. So thank you for watching. Please remember to subscribe to my YouTube channel, turn on the post notification bell so that each time I post a new video you'll be the first to watch it. See you in my next video.